Question number 76 states the solubility of Na2CO3 in carbonated water is due to the formation of, what is carbonated water? That is the water in which you have dissolved carbon dioxide, and if you try to dissolve sodium carbonate in it, then it is soluble. Why it is soluble? Because it forms NaHCO3. This would be formed there. It means where it is given? It's given in option 4. So I'll choose this option 4 as the correct option for question number 76. Now after this, question number 77, the total number of possible diatomic molecules of isotope of hydrogen will be. If I talk about diatomic molecule of isotope of hydrogen, there's the possibility of the formation of H2, that is 2 atoms of protium, D2, 2 atoms of deuterium, T2, 2 atoms of tritium. Further, D can be joined with H. Further, D can join with T also. And if I talk about H and T, there is also the possibility. So these are the combination which can be possible there. And on the basis of this, you can clearly see that the total number of the possible diatomic molecules of isotope of hydrogen will be 6. And that's given here in option 1. So my answer is option 1 for this particular question. Let's take question number 78. The temporary hardness of water can be removed by using. You have different options. Calcium carbonate, we have first option, then calcium chloride, calcium sulfate, and calcium hydroxide. First thing, the salts of calcium and magnesium are responsible for the hardness of water. If I talk about the temporary hardness, that is due to the presence of carbonates and bicarbonates of calcium and magnesium. Similarly, permanent hardness is due to the presence of chloride and sulfates of calcium and magnesium. So first 3 options can be discarded here. And if I talk about calcium hydroxide, that's a slake lime, it can be used for the removal of temporary hardness of the water. This is the Clark method in which it is used. So which method is it? This is Clark's method. And on the basis of this discussion, I can easily choose option 4 as the correct option for question number 78. Now question number 79. Formula of brown colored complex in brown ring test is a very well known test for the presence of nitrate. We know that in this case freshly prepared ferrous sulfate we take and it is mixed with the nitrate salt. And then slowly sulfuric acid is added and there is the formation of a brown colored ring at the junction of 2 liquids. So in this question it is asked the formula of brown colored complex in brown ring test. The formula is, I'm just writing here, that is FeH2O 5NO 2 positive. This is the cation that's formed, complex cation is formed and this is given in option 2. That's why I'm choosing it as my correct option. After that, question number 80, the volume of 6.8 V of H2O2. What is this? This is the volume strength of H2O2 that is given in the question. I just underline it. Further, required to liberate 224 ml of O2. So we need to just find out that volume of H2O2 which is required to liberate 224 ml of O2. As per the question, we can say that 1 ml of H2O2 on decomposition liberates 6.8 ml of oxygen gas. This is the clear thing that's given in the question. On the basis of this, we need to find out the volume of this H2O2 required for the liberation of 224 ml of O2. So simply we can say as 6.8 ml of O2 is liberated from 1 ml of H2O2, then definitely if you want 224 ml of O2, then what would be the volume required there? It would be 224 upon 6.8 ml of H2O2. And that is the final answer, which is 32.94 ml. On dividing 224 by 6.8, you will obtain this value. And this is the final answer, which is given in option 2. That's why this question has the answer, that's option 2.